manager for Kunak. Okay, she will be doing the training. Okay, she is the technical girl. Okay, so I will not be too useful in this training. Okay, so I will just remain here in case you have any doubt. But yeah, Irene will be happy to assist you. Okay.
Okay. So shall we start? Okay. So the training usually is divided into parts. Okay. The first one is more general about the different options for calibration, and yeah, and also the quality assurance and quality control process that we perform here at Kunak. And then the second part is the specific use of the tool we have for calibration. Okay. As you have probably some knowledge about the different options of calibration options, I will go through the first presentation quite quick, and then we will go more deeply in the second one. Okay, that is the use of the tool and yeah, how to calibrate gas sensors and particle sensors. Okay. Okay. So the first. Also, one thing is that please feel free to interrupt me at any time if you have any questions. Okay, no problem. Okay, let me share my screen. Can you see my screen?
Yep. Yes, I can.
Are you seeing the full screen or like the presentation mode?
The presentation mode.
Okay. I have always this.
It was full screen,
problem.
but now we can see your notes there as well. So
yeah, let me share the other screen better. Is it talking now?
yes, it's fine now.
Okay. So yeah, this is the first presentation. So these are the different parts. As I already mentioned, I will go quite quick. Okay, so I will explain first the quality assurance and quality control manufacturing process and standard operation procedure, and then I present the different options for calibrating or correcting the sensors. Okay. Yeah, and then the difference between gas sensors and PM sensors, and just what we recommend for maintenance on field. So as you probably know, we here at Kunak, we perform a long process of that to ensure the quality of the equipments that we deliver. So we have this cycle, okay, with different steps, and the different steps address the different challenges that are that the units should face. So the first step, I don't know, you see my mouse or not?
Yes, I can see you.
Okay. So the first step that we do is the sensor selection. So this is a step that we already have done for the different sensors. So we select several providers, we test different sensors, and we select the best one that are suitable for the application. And then once we have selected all the sensors, best sensors in the market, we can start our quality control and quality assurance process that is carried out in our factory. Okay. The first step will be the characterization, of these sensors. So as you know, excuse me, I think I'm hear some echo. Maybe you can mute yourself, please. As you probably know, the gas sensors are impacted by the environmental conditions, mostly temperature and humidity. And these the environmental conditions can influence the sensor signal. So for example, they can give with high humidity transients, for example, false positives and other impacts that decrease the accuracy of the sensor. So in the first step, what we do is to characterize how these variables impact on the sensor. And then each sensor is characterized across the full range of temperature and humidity in our laboratory. Once characterized, we know how the sensor responds, so we can apply the correct algorithm to mitigate the impacts of these variables. Okay. Once we have applied this algorithm, we calibrate our sensors. So the idea is that we don't manufacture the sensors; they come from a provider, and we have no control in sensor calibration. So we perform here calibration in our lab in order to check the sensitivity of the sensor. And then the fourth step is the validation. So in this step, we verify that the algorithm that we have selected for characterization and the sensitivity are the correct one for that sensor. And then the Kunak certificate can be issued. These are all the steps that are performed in our factory. And then at that time, the unit can be deployed on field. So the fifth step is the deployment on field of the unit. And then once it is deployed, we can observe different issues related to the baseline and sensitivity drift. So in order to do that, the solution is to perform a regular calibration or correction using our tool that I will present later in this presentation. Okay. What we do with this tool is to correct the drift in the baseline, and also we can correct the decrease in sensitivity. And then after that, the last step will be the cartridge replacement. So once the cartridge has arrived to the end of its life, the cartridge should be replaced, and we start all over again with a new gas sensor. Okay. Any questions?
Yes, I just want to find out what temperature range and how accurate are they at high temperatures, the cells?
Excuse me, what temperature range?
Yeah, what temperature range can they get to, and at what temperature is it good to function them at? Because we've got a site that gets up into the 42s. How accurate are those sensors at 42 degrees Celsius?
So we have some technical specifications for each sensor. I don't remember them by heart. I think they are up to 40 degrees. I'm quite sure. And the accuracy depends on the temperature, but also the humidity transients. It's not the same if we have 40 degrees with not too much variation of humidity, or if we have that with high humidity transients. That changes the effect that is produced on the sensor signal.
Irene, when deploying the Kunak in the field, how many days would you allow for stabilization?
How many days, you mean?
Yeah, for the gas sensors to stabilize.
Yeah, a stabilization period depends on how much time the gas sensor was turned off. So, for example, if we just move, I don't know, from my office to outside and we turn off and on, probably in few minutes it will be ready. But if the device, for example, come from Europe to Australia and you have to turn it on, maybe you will need some days. We recommend between 2 and 1 week. So 2 days and 1 week for stabilization.
Okay, thank you.
Do the cartridges stabilize though if they're on the shelf here? So say for example, we've got stock and we have a request to deliver it next week. Is there any way that we can improve the sort of the acclimatization of the cartridges?
They need to be connected to the unit. So if you have it in a shelf in their bag, they are not gonna stabilize. You need to connect it to the unit, and then you can start counting the stabilization period. So for example, I don't know if you have a unit in your office, you probably know that you will need some cartridges, you can let them connect.
Okay, that's good.
Okay, any other questions? Good. So we can continue. So just to make a difference between what is a calibration and what is a correction. So for the calibration, what we do is to adjust the sensor signal based on a reference concentration. So we should know the concentration of the gas that we are measuring. That can be, for example, by using another instrument with higher accuracy, or by using a gas cylinder with a known concentration, okay? The correction is the procedure to adjust the sensor response, but without using any external reference, okay? Correction, we can perform it remotely, and we don't need, the main difference is that we don't need any external reference data. So I will show you later how we can perform this correction, okay? The difference also is that for correction, we can reduce the error and we can mitigate the drift, but we cannot know exactly the measurement uncertainty because we have no reference. And to calculate the uncertainty, we need a reference value. So the different options for calibration and corrections are, for calibration, we have calibration through collocation with a reference station. So in that case, we are comparing our instrument with an instrument on the reference station. The characteristic of this method is that, of course, we need a reference station. The duration should be at least 7 days in order to have different concentrations and conditions. We can perform baseline as well as span calibration, and then we can calibrate as many gas sensors as pollutants are measured by the reference instrument in the station. The second option will be using a gas cylinder connected through the gas hood. The gas hood is this element that you can see here that allow to create a path for the gas to circulate over all the sensors, okay, and allow to connect this cylinder of known concentration to the unit. For this method, we will need the calibration gas cylinders as well as the gas hood. The duration is very short, so yeah, 5 minutes, 10 minutes of the calibration gas passing through the sensor will be enough. We can perform baseline if we use zero gas and span calibration, if we use the target gas. We can calibrate as many pollutants as there are in the calibration gas, and then the data can be traceable back to these standards based on the cylinder that you use. Is that okay? Any questions about the two calibrations method?
It's all good.
Fine. Later with the tool, I will show you how to do this calibration with a reference station. I'm not sure if you will use it in your with the units you have deployed, but I think it's worth to see it as well. And yeah, maybe in the future you will use this feature. Then for the correction, we have baseline correction without reference. So in this case, we don't need reference station or calibration gas cylinders. We just need historical data. Usually more than 7 days is needed. Duration, in 1 hour, maybe we can calibrate a whole device of 5 sensors. And this method only allows to do baseline correction. So we cannot correct the span. The span can only be calibrated because it's the sensitivity, and we need to have non-concentration in order to check the sensitivity. And this method can be applied to all pollutants. And then the last one is the automatic baseline correction. This method is automatic. And so we don't need any reference station or calibration. We just need a known background concentration, like for example, CO2. So this method is only for baseline correction, and it is only available for methane and carbon dioxide as sensors. Okay. And just very quick about the PM sensors. So PM sensors, all I explained before was for gas sensors. So for PM sensors, they are mainly affected by the specific particle type. Okay. So with our calibration tool, we can apply a correction factor, the same as in equivalent instruments, in order to adjust the sensor signal. In this case, we have 2 options. The first one is the same as with the gas sensor, a collocation with a reference station. In this case, we recommend a duration minimum of 14 days, but recommended of 30 days. And with this, we will do a regression, and we calculate the factor that should be applied to the sensor. The other method is using the M-search factor. Okay, the M-search is a certification that that we achieved last year, in which if we use the factors that the M-search certified, we are able to provide indicative measurements for particles. In this case, we don't need a reference station, and these factors are already implemented in all of our sensors. So if you have PM sensors, you are already using these factors. Yeah, and that's are I would say, 2 options for PM sensors. The first one, I will show you later also how to perform this calibration with the tool. Any questions about the PM calibration and correction options?
Sorry, you mentioned that the PM sensor works basically based on the specific particle type. So how you can use that factory calibration for the site while the particle is different?
Yeah, so the way of the sensor works is similarly to equivalent instruments. I don't know if you are familiarized with these equivalent instruments.
Which one?
Theum or Palas, this kind of, so they use a factor, okay, depending on the particle. The thing is that in order to determine that factor, you will need to use the reference method, which is the gravimetric method. So in order, if you want to have the most accurate data and you want to calculate the factor for your your site-specific factor, you will need to go with the reference instrument with a gravimetric method and then put it there and calibrate your TEM, for example, using that method. And that is something that is not viable for cost, for many reasons. So what these equivalent instruments, as well as our sensors, works is that they are certified with a factor. In this case, is msearch, and for equivalence instrument is the same process, but I don't know by heart the name. And they have a factor, and they assume that depending on site, they will have some error, but this is inherent to the measurement method, because we cannot use the reference method, which is the gravimetric method, in any in all the sites. So by using these factors, we minimize the uncertainty, but we assume that we have error in the measurement.
And what range of error are you talking about? 10%, 30%?
It will depend on the site, because it is not the same if you are measuring in a mine or if you are measuring in a city. Probably in a mine you will have more error because the factor was calculated in an environment maybe more close to a city than a mine.
Okay.
Any other questions? Okay. Yeah, this is the last part. I think is also included in the second presentation, so we can maybe move to the second presentation, and we will go to the scheduled calibration and correction maintenance once I have explained to you the calibration tool. Okay. 1 second. Okay, can you see the second presentation, right?
Yes, we can.
Okay, so yeah, first of all, just a little recap about the operation of the sensor. So let me put the pointer again. Yeah. So this is a workflow of the different actions we can take in order to maintain the correct operation of the sensor. So first of all, we install the sensor, and then, as we discussed, the gas cartridge should be stabilized at least 5 days. As I already told you, it depends on the day that the time that the sensor was off, but yeah, at least 5 days should be enough. And then we have to check if there are any operation alarms or warnings in the Kunak cloud, and also visualize the data in order to check that there are no weird signals or lack of signals or anything that we can see is not normal. In case we have operations alarm active, we should check the help notes related to operation alarm and warnings, because maybe it's something easy to solve. If the problem is related to the cartridge or the end of life of the cartridge, we should probably replace the cartridges. Okay. In case it is not related to the cartridges, can you solve the problem yourself with the aid of the help notes? If yes, fine. You go again to check your alarms. In case of no, you can contact our support center, and our colleagues from support, they will be happy to help you. So once you have solved all these operational alarm and warnings, in case you have it, do you need a calibration? In case of need of calibration, you need to use the calibration tool. And depending on if you have access to reference data or not, if you don't have access, you can only perform baseline. Sorry, there is a typo here, is baseline correction. Okay, so we will be able to mitigate the drift and we don't use any known concentration. If we have access to the reference data, for example, reference station, we can perform baseline calibration and also span calibration, okay? Because we will have this reference concentration to characterize the sensitivity. So once the calibration is performed, we don't need any calibration anymore. So do we need any validation? If yes, we can use the validation tool that is included in the Kunak cloud. Or if not, we just go to the endpoint that is the achievement of accurate data. Okay. In order to maintain the accuracy of the data, we need to perform periodical supervision. That means that periodically we need to check the operation alarms and warnings and also visualize the data in case there is something weird. And that is more or less the workflow of operation and maintenance of the cartridges. Then for the use of the tool, we are gonna focus on this part only. That is, this part. So just a reminder, just what I already mentioned, that the performance of the sensor should be periodically checked or calibrated in order to ensure that the sensor provides reliable readings. Then the calibration periodicity depends on the sensor properties. So not all the sensors are the same. And then also depends on the environmental conditions and the user application. For example, if we are working on very dirty environments, it is likely that the sensors get dirty as well, and the performance degrade a little bit quicker than in more cleaner environments. And also the user application requirement for the accuracy and reliability of the readings. So it is not the same. There are some users that only want to check, for example, leakages, and they don't care about if it's 50 ppb or 200. They just want to know if there is something that is emitted from their facilities. And there are other applications in which accuracy, they want to know exactly how many ppbs are measuring. So that the calibration frequency will depend also on these requirements. Any questions about the standard operation procedure? Fine. So as I presented in the previous presentation, there are 4 options. For this automatic baseline correction, we don't need to use the tool. The tool only will be used in this case with reference station, gas cylinder, or baseline correction. As I mentioned at the beginning of the training, most of the sensors are affected by temperature, humidity, and cross sensitivities with other gases. And these effects have a nonlinear response in the sensor. So what we do at Kunak, we have developed an algorithm that convert this nonlinear response into a linear response. The advantage, the main advantage of doing this is that in order to calibrate the cartridge, we require only 2 points. That is the 0 and span. Okay, so 0 the baseline and span the sensitivity. Yeah, so the advantages compared to other calibration methods, we just need 2 data values for reference. So we don't need a huge amount of data to apply the calibration. And also this model is applicable in any case and ambient conditions. That means once we have calibrated our sensor, it is calibrated for any environmental condition. Just a couple of considerations that I will show you while using the tool is that for calibration, we need to use the parameters that are called GC, which stands for gas concentration. I don't know, I guess you have the operation package, right? Yes. Okay. So you are used to see GC and GCC values, right? GC are the raw data, and GCC is gas concentration corrected, so the corrected data. In this example, for example, yeah, the data that is negative is shown as 0 values. But I will come back later to this part when using the calibration tool. Other considerations, that we have to keep in mind while calibrating is that we need to use nighttime for calibration. Okay, why? Because temperature and relative humidity are more stable, so it is easier to find the stable periods for calibration. And then regarding the span calibration, again, we will use GC parameters. We try to avoid humidity transients. As here you can see, for example, we have here some concentrations, but we have also an humidity transient here. So it is better not to select these points for calibration. And also other consideration regarding span calibration is that we need a minimum concentration in order to use that point for calibration. That I will show you a table later with our recommendations, but it's the same as if you calibrate in a laboratory with a gas cylinder. You need to use minimum concentration. Otherwise, you will have a lot of error. If you are going to calibrate your sensor with 20 ppb, probably, and then you are going to measure 80 ppb, probably your error will be big. So it is better to choose at least values that cover the full range of measurements. Okay, I think, let me check. I think maybe we can start. Yeah, we can start using the tool, and I will show you how to calibrate with a reference station. And then I will show you some other considerations that are needed for baseline correction. So it will be better to divide it like this. Okay, I didn't find a reference station that you are using. Correct me if I am wrong. So just for as an example, I will show you how how to calibrate using a reference station with a device that we have in Glasgow. Okay, as you can see here, the Kunak Glasgow device is installed close to the reference station Glasgow Townhead. Okay, in that case, we can use a reference station to calibrate. If we have our unit far away 1 kilometer from the reference station, we cannot use this station, okay, for calibration. So first of all, we need to go to operation, gas particle and calibration. Okay. And we are gonna select baseline calibration. We need when we use reference station, we need to perform always baseline calibration and then span calibration. The device we want to calibrate is Kunak Glasgow, and we are gonna calibrate, for example, NO. Yeah. Yeah. Here we have to select reference value, okay, and then the start date. In order to find the period we will use for the calibration, as we have the reference station, we need to check the data in the reference station. So we go to operation data, and we are gonna look at the data of our unit. And the reference station. For our unit, we will select the GC value, and for the reference station, it's 1 hour average data, if I'm not wrong, because reference station usually have hourly values. We are gonna select the last 2 weeks of September, because we don't have the data from October in this station. Okay. As you can see, we have in blue the data corresponding to our unit, and then I'm gonna delete this, and then the data corresponding to the reference station. As you can see, in a general overview, the data are quite similar, but this is just an example in order to show you how to use the tool. So for baseline calibration, we are gonna try to find a period, a nighttime period, in which concentration values are close to 0. So for example, we can use this period, that is at the end of September. Also, when you perform a calibration, it's better to use the most recent data. So if you have data from the 15th to the 13th, if you have some values that are correct on the 13th, it will be better, okay? So in that case, we have here a period that is nighttime. You can see the concentration during nighttime are more stable. So for example, we can use data from 12 to 1, which is 0.96, 0.8, okay, in the reference station. And you can see the values of the sensor, which are more frequent. That is the reason why we see some noise. They are a little bit lower. So if we want to use this period for calibration, we just need to go here and say, okay, the reference value was 0.9 in that period. And I want to select 30 of September from 12, 1 hour. Usually we use 1 hour as a duration for the calibration period, but sometimes you can find shorter periods. For example, for ozone, these periods are difficult to find, and usually it lasts 15 or 30 minutes. It is very difficult to find 1 hour. So that will depend on your on the data, okay? So in that case, we have 1 hour of a stable value, so we can choose 1 hour. And then we can select the period in which we want to apply this calibration. For example, we are going to select the same period as the data we were saying, from the 15 to the 30, and we can select here the reference device. So here we select the reference station, the parameter was NO, and we click on next to see how the calibration, how the sensor signal will be modified with this calibration. Okay. As the sensor was calibrated, the difference between the red line, which is the system not calibrated, and the blue line, which is the system calibrated, there are not too much different. That is because it was already calibrated. As you can see, in the period that we select, concentration should be, with the noise, it's difficult to see, but the value should be 0.9, the average value in the period we select, which is from here to here. And then regarding the calibration tools, there are some statistics that are calibrated. As we have a reference, there is a regression line that is calibrated. As we only modify the baseline, so the offset, the R square do not change. Then we have the main absolute error, which is very, very low here, 1 ppb. And then the expanded uncertainty. And then we have also several options here to mark this calibration as a factory calibration. In this case, this option is only for Kunak, for the factory calibration we perform here in our facilities. Then we have the option to rebuild the data. That means that if we select this data will be rebuilt, and if we are gonna check this data, we will see the data with the new calibration parameters. This data will be marked as GCC, so gas concentration corrected, because it has been modified. Okay, for that you can see a tag. Here is temporary because we do not modify these values, but in case these values have been modified, the tag that is shown is corrected. So that is the way that if data has been modified, we can follow the trace. Okay. But if we check the GC values, they will be always temporary and they won't be modified. So the raw data that we acquire with our units will be always there, and we can see, and maybe we can see this later with your data. So I don't know if I was clear in this point when we rebuild the data. We can reveal the data, but the raw data always stay there. Okay. In case, for example, we perform a calibration and 1 week later we realize that we made a mistake, we can rebuild again the data with new calibration parameters, and we will have our calibrated data and our raw data. The last part of this menu are the CMMS options, in which we can select to register the calibration action in the logbook. So in that case, it is traceable, the calibration, and also other users can know if someone has calibrated this device before. We can add also the statistics to the logbook action, and we can select if this can be viewed for all users or not, and also generate a notification when we calibrate. Any questions about calibrated using a reference station?
Sorry, can you explain that rebuild historical data? So can we use this calibration to rebuild the data 2-3 months before?
Yes, we can rebuild back in time whenever we want, but we have to keep in mind that if we select, for example, today, that is October, I am reviewing some data from July, and I have my reference data, my reference station data from July, and I perform this calibration with the tool, and I say, okay, perfect, I want to rebuild the data of July, and I can do it. But if I apply that calibration, my device will take those parameters from the calibration. That means that today it will start to use those parameters. So maybe if you are using that, you can rebuild your data, but you will need to calibrate it again after that in order to ensure that your device will be calibrated for the conditions that are now. I don't know if I was clear.
I didn't catch that actually. Yeah. So if I use the data in September, can I use to rebuild data back in June?
I don't recommend to do that because conditions are different in September and in June, and baseline. So maybe I forget to explain that before. So baseline, it depends on average temperature. So we recommend to do, for example, baseline calibration when the average temperature changes more than 10 degrees. So that means we recommend to do this baseline calibration once per season. Okay, so probably if you are calibrating your baseline in September, it won't be good for a calibration for a period in June. I don't know. It depends on also the location and the seasons, but probably it won't be good. What you can do is sensitivity. Sensitivity can be calibrated, but baseline, no, I don't recommend to do it.
So basically we need a baseline calibration or adjustment every season.
Yeah, that is what we recommend.
But for span calibration, we don't need that every season.
No, because Spanish sensitivity is how much the sensor signal respond to the target gas, and this is not dependent on the average temperature. So it is not needed to adjust it every season.
Okay.
Okay, regarding the data rebuild, we can see it later when we do the baseline correction that I plan to do it with your data. So maybe we can apply a calibration and see how it changes. Okay, because this is data from another experiment and I cannot modify it now. Okay. Then once we have baseline calibrated, we can click on apply in order to apply all the changes. I'm not gonna do it, but yeah, once you click apply, all the changes take place.
Sorry,
Once we
this is
have,
apply is just applying the correction for the period that we selected at the start, yes?
yes.
Okay.
So if you select apply, the device will take the calibration parameters that has been calculated here. Okay, and start using from now onwards. If we select also yes here, it will rebuild the data with the new parameters and start using the parameters for the from now on.
Okay, got it.
Okay. So I'm not gonna apply. Once we have the baseline calibration done, we can do a span calibration. Okay. Again, we select the device and the gas. Here, we need to select a reference value. In this case, this I will show you later the table with the recommended values for each pollutant. We come back to the data we have for the reference station, and for the minimum value to calibrate NO is 40 ppb. Here we can see, yeah, there is this value that is very, very close to 40, but for the example, we are gonna use it. So we say, okay, we have this value that we can use for calibrating the span, and it's 40.58 ppb. Okay, this value corresponds to September 18th, 7 in the morning. These are hourly values. So 7 in the morning represent the average data between 6 and 7 in the morning. Okay, we have to consider that. So now that we have selected this period for the calibration, we come back to the tool and select the period. So the value was 40.58, 18 September from 6 in the morning to 7. It is important to check the time zone, okay? When we are in operation data, we saw here the time zone. In this case is UTC, and here is UTC plus 1. So we need to have same time zone in both, because otherwise we will be selected other different data. Now we have selected the period. So again, if we want to see how the calibration is applied in an interval, in a period of time, we can go again 2 weeks of September. And then we want also to visualize the data from the reference station for comparison. And click on next. Something happened. Let me check because there is something wrong. I don't know why. Okay. Here is the error. I put October instead of 18 September. Sorry. Okay. Now it looks much nicer. So again, as this device was already calibrated, the calibrated and not calibrated signals are quite similar. If we have a look at the span, yeah, the difference is few ppbs. And now, excuse me, we have again very similar R square because yeah, it was almost already calibrated. Similar error, and we decrease the expanded uncertainty. And again, we have the same option. So if we want to mark it as factory calibration, if we want to rebuild the selected period, so from 15 September to 1st October, and the register option. So if you want to register the action in the logbook or add the statistics and generate a notification. So it's very similar to the baseline. The only difference is that we need to find a point in which concentration exceed a limit value. Okay, that is the only difference between the baseline calibration and the span calibration in terms of use the tool. Do you have any questions about this part? Fine. So we can continue with the presentation. Yeah. So we finish the calibration with through collocation with reference, and now gaswood calibration will be similar. The use of the tool will be similar. I will show you a bit how we can. Yeah. So for the gaswood calibration using the tool, we will introduce the gas. I'm gonna put the pointer. We will introduce the gas into the device, and we know the time. We know, for example, that if we are calibrating now, we are introducing the gas at 9 a.m. the day 28 October. So when we are gonna use the tool, we will select. I will show you very quick. What we need to do in case of we are introducing, for example, zero gas, we select baseline, we select our device, okay, and the gas we want to calibrate, the baseline. We will introduce the reference value that for zero gas will be 0, and then the period we want to use for the calibration. If we are introducing the gas today from 8 in the morning, 15 minutes, we just need to select here the time. So today, 15 minutes, 0 ppb, and click on next. And this will and yeah, we can apply it also for a time period. For example, we could imagine we want to see the data using these calibration parameters for the last week, and then click on next, and it will be recalculated using the data during that period in which we were introducing the gas. Okay, this I cannot do it now, of course, because we are not using the gas hood, but that will be the way to do it. Very similar to the other method. Okay, and the last part that I think is the most useful and I think the method that you will be using the most is the baseline correction without reference. So as I mentioned before, the baseline drift depends on the variation in temperature, in average temperature. So when the average temperature changes more than 10 degrees, the baseline sensor has a significant drift and is recommended to correct it. In order to correct it, we don't need to use reference data. Why? Because gases usually reach minimum concentration during a certain part of the day. This minimum concentration usually is nighttime for most of the pollutant, except for ozone, which is at the beginning of the day when the sun is rising. So knowing that, it is possible to find periods during night that we can use to correct the baseline. So it is not difficult. The use of the tool is very simple, but you need to practice a little bit in order to find this period easily, okay? And I will show you today, and I will give you some tips in order to find these periods. Then the span drift correction. So we cannot do it right now, the correction of the span. It is something that will be coming very soon. So as I mentioned as well, the sensor suffer for a degradation of the sensitivity. So that means that when the sensors are aging, the signal is decreasing. And usually we have determined that the span decrease its accuracy between 10 and 20% in a year. So if we want to reduce this uncertainty, we can perform an span calibration. Okay, as I showed you with the gas cylinders or a reference station. And also, we are now implementing an automatic correction of the sensitivity. So knowing that the decrease in sensitivity of the sensor, we plan to introduce an automatic correction of the sensitivity over periods of time in order to decrease the span drift error. Okay, so coming back to the baseline correction, as I mentioned, very important to do it during night hours, okay, when the environmental conditions are very stable. Then this is the table I mentioned before with the requirements and the recommended baseline values when we apply the calibration. So we have here the different we have here the different gas sensors. This is the baseline Kunak requirement. So concentration, for example, if we want to perform a baseline calibration, the concentration should be always lower than 300 ppb, for example, in the case of CO, or 6 ppb in the case of NaO. Then we have recommended values. So these are the values we usually use for baseline correction. So very close to 0, of course. And then the recommended period for baseline calibration and correction. As I mentioned, for most of the pollutant is during night, except for ozone, which is between 5 and 8 in the morning. Then for the span is the opposite. So we want to have high concentration. This is the minimum requirement. So for example, in the case of NaO, it's 40, but we recommend the highest concentration, okay? So if you have, for example, a gas cylinder of 1 ppm, it will be perfect for doing the calibration. Okay, and now we are going to the use of the tool. I have been checking a little bit your devices. So I'm gonna enter in your account. So for example, if we go this one, and I saw you have NO2 sensor, ozone, and SO2. So I'm selecting the GC values, okay? Is what we use to see if the devices are calibrated or not. Select 1 week. Maybe we can see it one by one. So this is 2 weeks in order to see a little bit more data. Okay. First of all, we need to check if this device is calibrated. How we can check that? NO2 usually during night, it should achieve 0. Maybe not all nights, but as we have historical data from 2 weeks, we are able to see if we are close to that value or not. For example, here is morning. Morning as well. Okay, here we have 1.6 at 3 in the morning. You can see, maybe I can zoom in. Here. We need to find some stable periods during night. So here it's a little bit flat. It's 1.6. Not too bad. Here again. This is morning. Here 0.8 during night as well. So I would say that this device is quite calibrated. Okay. If we look, for example, at ozone, it has a different pattern. Okay. For ozone, we need to, the minimum values, if you remember in the table, should be found between 5 and 8 in the morning. Okay. So if we have a look at the different minimums here, we should check the different times. For example, this one, I'm gonna zoom in. This one is minus 2 ppb at 6 in the morning. So it can be a 0 value, and it can be that is little bit decalibrated, okay? Now we are gonna take this one that is minus 8 ppb. Ozone, due to the chemistry of ozone, it is likely that it does not reach 0 in several days. So that means that maybe in 2 weeks, we are gonna see only one period in which the ozone is 0. That is normal. And I would say ozone is probably the most difficult pollutant to calibrate. But it is a matter of practice to find these periods. Okay. So here we have minus 8 at almost 6 in the morning. That could be a sign that this device is not calibrated. Here we have again minus 4. That could be not a 0, but close to 0. Then we see this minimum that is at 10. This is not in the period when we calibrate ozone, so we should not use this point for calibration. Okay. This point again is during night, so I won't take it for the calibration. Looking at this point, I would say that the minus 8 would be the most suitable. So here we have flat period, very short, okay, from 5:46 to 6:11. So we can take this period for calibration. Now, as before, we go to gas and particle calibration. I will open in a new tab. We select the device we want to calibrate. Is what was the name? Number 7, ozone. Also, it is important, that is the reason why I check NO2 before, because NO2 should be calibrated first, because the ozone, the NO2 interfere with the ozone sensor. So in order to calibrate the ozone sensor, we have to have the NO2 sensor calibrated before. Okay. In any case, you will see this advertisement when you try to calibrate a sensor that needs to have another sensor calibrated before. You will see this warning. Okay. Now, as we are calibrating baseline, we are gonna set the 0 value, the start date. So it was the 26th October, and it was 5:46 for 15 minutes, because 30 minutes was too much. I don't know. We can use 30 minutes. And then we click on next. And for example, imagine that we want to check this calibration for the last 2 weeks. to see if that fits well all the data. In this case, we are not selecting any reference data because we don't have it, okay? We are doing a baseline calibration and we don't need any external reference data. As you can see here, there is a difference between the no calibrated values, so the red ones, and the blue ones that are the calibrated values. If we saw the calibrated values, now we see, like in this point that we set as 0, now the concentration is 0, okay? And it is true that other values does not reach 0. It comes close to 0, but it does not reach 0, which is quite normal for ozone. And then we can check here this value that is, these are during night. This, 5 in the morning could be a minimum, and you see it's almost 0 ppb. So it can confirm that the point that we select was the correct one. Okay, and now you can see the difference between the raw data and the calibrated data. Again, we have the same options. So if we want to rebuild this data, we can rebuild. And then when we see our data on operation data, we will see these values, the calibrated ones, as GCC, and we will see the red values. The red values as GC. Okay, and then again the same options. Do you have any questions about this baseline calibration using the tool? No? All clear?
Sorry, for ozone, you mentioned that we need to select the period of time between 5 and 8. How about the others? Can we just go with the minimum, any minimum with the other gas at night?
Excuse me, can you repeat the question again?
With ozone, we had other minimums, but they were not between 5 and 8 a.m. That's why you didn't select those for calibration. How about the other gas? Is there any criteria with the other gas to select?
For the other gas, we are gonna perform a calibration now, because NO2 was okay, but we have in this equipment an SO2 sensor that needs to be calibrated. So my plan is to do it now, also to show you how to calibrate sensors for other sensors that are in night periods.
Okay, that'll be good.
Okay, this one, I'm not gonna apply because I don't know this device, which is the client that is being used, but yeah, if you click on apply, the calibration will be applied, okay? Then if we want to calibrate the baseline, now we are gonna do it for SO2. For SO2, you see here, you have to have NO2 and ozone sensors, and also CO, that I don't think you have in this device. Also depends, if you are in an environment where there is no significant concentration of CO, it is okay to not to have it. Okay, then for the calibration, we are gonna check the data of SO2. Here, I don't know if you are able to see some flat periods. For example, here, it's quite flat, right? Here, a little bit. Also here. Okay, and if you see the times are all during night times. Even here is noisy. So here is easier than for ozone. As you can see, many flat lines. Okay. For example, we can use this one that is more recent than the other ones. Okay, I'm gonna zoom in. This one from 4 in the morning to 5. Okay, and it's minus 14 more or less. Okay, so we are gonna say that is 0. 23rd October at 4 in the morning, 1 hour. Okay, just maybe even flatter here. So from 5:16 to 6:16. Five 16, 1 hour. Then we can select the same period as we are seeing in the operational data. So from 13 to today. And we don't have any reference, so we don't have to set anything here. We click on next. And then here there is a difference as well. So, for example, if we see the point we use for the calibration, that was that one. Before was minus 14 and now is minus 5. Why is minus 5 if we set 0? This is a specific case for SO2 that is in order to avoid false positive. For the other gases, if we set 0, is 0. Okay, we should come here and see this line is 0. But for SO2, in order to avoid false positive, we set it at minus 5. Okay, this is just a particularity of this gas. But now you see there is quite a big difference between the raw data and the calibrated data. Is this a little bit easier than ozone?
But still, after adjusting baseline, most of the data are negative. So are you happy with this data?
Excuse me?
Even after adjusting the baseline, the corrected data is still negative most of the time.
Yeah, because in that location, there is no SO2. That's the reason why. So if you see the data, the final data, most of the data will be 0. I don't know. We can check the location. Yeah, it's a residential, so I don't think there is sources of SO2 around a residential zone. That's the reason why.
Yeah, so we expect to see 0, not negative 5 or 8.
Yeah, but if you go to because we are seeing DC data, so it's the raw data, but we see the corrected values. There are GCC. Let me unselect this. This is what you are gonna see.
Okay.
That all these negative values will be limited to 0. So you don't see any negative value. You only see it as a raw data from the sensor.
Okay.
Yeah, and that's all. Now the use of the tool is a matter of practice, and I encourage you to try and do several tests using the tool, and try to do it yourself. If you have any questions, you can contact me, send me an email with your questions, or even if you have calibrated one sensor, you can ask me, hey, please have a look and let me know if it's okay or not, because yeah, it takes a little bit of time, but then it will be fine. Okay. Yeah, so the last part of the calibration is the gas particle calibration. Sorry, the particle sensor calibration. So far we have been talking about gas sensor and the use of the tool for gas sensor. So now we are gonna see how to use it for PM sensor. As we saw before, the only method to calibrate the PM sensor is by using a reference station or a reference instrument. For this, we will need several weeks for comparing the data, and we can calculate the regression line or the slope through the origin. Okay, this is calculated by the tool. So now I will come back to the tool again, and as you don't have reference station, we will come back to the example of Glasgow. Okay, this example, which has also particles. Yeah, so first we are gonna see the data for the reference station and the unit for PM 2.5. And we are gonna see the data of September. As we recommend 1 month of data, we are gonna select the whole September. For the station, I have to select the early values. One second. Sorry. I made a mistake with the what are they? Is this one the reference station? Okay, so now we have the data of our device in red and the data from the station in blue. Okay, you see there are some difference. They are going quite similar, but there are some difference. So the difference with gas sensor, when we calibrate particles, we don't have to select a period of time of 1 hour or something like this. We need to select the whole period. So in that case, we need to go here to particle calibration, and we have 2 types, manual and linear regression. I will explain linear regression first and then manual. Okay, for this one, it's against reference, so we need to have a reference station. Our device is a Kunak Glasgow. Okay, and now the period we have to select is the month in which we have the date. Okay, we select September. Reference device. For our PM sensor, measure PM1, PM2.5, 4, 10, and total suspended particles. In this case, we want to compare to a reference station that only has PM2.5. So here we have to select the reference station and the variable PM2.5 in this case. Okay. So for the calibration, the tool will take the PM2.5 values of the reference station during the month, this month, okay? And then it's gonna do a regression and calculate the coefficients of this regression line. This regression is forced to the origin, which means that the offset will be always 0, okay? As you can see, it's marked on gray, and this cannot be modified. So it has calculated a factor for PM2.5. We will need to use this factor for the other variables if we don't have the values, okay? As you can see here, parameters of PM2.5 are less than those of PM1 or greater than those of PM10. That means that we have to put this here. And yeah, sorry, I forgot that in that station, we will have also PM10, sorry. We should have PM10. Yeah, so reference station usually have, usually measure PM10 and PM2.5. So what we usually do is we use the factor for PM2.5 for PM1 as well, and we use the factor for PM10 for PM4 and total suspended particles. Okay. Now, if we click on next, this factor will be applied to our sensor signal, and we will be able to compare with the reference station. Now we are gonna go one by one. Yeah, PM10 first. So in red is the raw data of PM10 of our device. And then in blue, the calibrated data. You see there is a difference. And this light red is the data from the station. So now, as you can see here, for example, in this zone, calibrated data matches quite good the reference data. Okay. And here there is the some metrics. As we are using a reference, the cloud is able to calculate different metrics. Keep in mind that these are daily. Okay, so R square, as we are applying a factor, it should not be modified. So before calibration for PM10 was 0.9 and after calibration 0.9, and the same for PM2.5, it has not been modified. But for example, the mean absolute error, it has been reduced from 5 to 1, and in this case from 2 to 0.6. Also, the expanded uncertainty was reduced to 100 from 111 to 21. And for PM2.5 from 69 to 7%. If we have a look also at PM2.5 data, we have the reference, the calibrated values are very, very similar. And then the raw data, little bit different. So we see this calibration has improved the accuracy of our sensor. And again, the same options that we had in the other calibrations. Do you have any questions about the particle calibration using a reference station? Okay. No question. I will show you just the last option of the particle calibration. So here we have two options. This one is the one we just used, in which the tool do a linear regression between the reference data and the data of our device and force the origin. So we only have the slope, and this is the factor we apply. In the case of a manual, we are gonna see, we select our device. We select again a period. For example, again, we select September. And imagine that you have reference data, for example, from another instrument, and you have it in an Excel, and you have calculated the regression yourself. So you have the data of an instrument, the data of the Kunak instrument, and you perform a regression in Excel. And you have calculated your regression factor. So you can introduce it directly here, okay? We can say, okay, pues 150, imagine, okay? In this case, we are able also to set the offset, but we don't recommend to set the offset. We recommend to force through the origin, because if the offset it's of some units, maybe you won't see very low concentrations. So that manual option is just to introduce factors if you have calculated them outside of the Kunak cloud. Okay, it is just to show you that this option also exists. Okay, that is all for particles. Just the very last slide of the presentation is related to the calibration and correction maintenance. So, as you will probably know, most of the sensors last between 12 and 36 months, depending on the gas. And yeah, most of them last 24 months. The performance of the sensor is degraded over time because of the natural loss of the electrochemical capabilities of the sensor. So for that reason, it is recommended to do a baseline correction every 3 months for most of the sensors. So as you can see here, in this table, we have the different gas sensors and the different type of calibration or correction that we can perform. For example, in the case of CO, 1A, that means that we can calibrate it through a collocation with a reference station. And as it is a gas, we can calibrate baseline and span. We can use option 2, which is the use of a certified calibration gas cylinder connected through a gas hook. And also we can use option 3, that is the baseline correction without reference. Okay. Which is the frequency, the recommended frequency for to perform this correction and calibration? We recommend always to do it after deployment on the field, a baseline calibration, and every 3 months. And then it is mandatory to do it every 12 months. For the CO2 sensor and the methane sensor, they have this automatic baseline correction. They do not need any correction in their in any period. Okay, and in the case of the particles, it's a little bit different. So we have the certification, so we don't have to do anything, or we have the option of using a reference station if we want to use it. And then, yeah, we recommend to check it after deployment on field, and then every 12 months to check if the sensor is working well, and if not, maybe it could be needed to clean the sensor. But this strongly depends on the environment in which we are operating. As I mentioned before, for example, the difference between a mine or a city. In a city, it is likely that we don't need to clean the sensor at any point of their lifetime. But if we are working in a mine, it is possible that every, I don't know, 6 months, maybe, or 1 year, we have to clean the sensor because there will be a lot of dust and can be, can cause some problems in the sensor. And that is all from my side. I don't know if you have any questions about this maintenance.
It's a question about the maintenance. When we say for SO2 3 monthly, what type of calibration or correction we need to do? Is it just baseline adjustment or?
Yeah, this is for baseline correction.
So after deployment and every 3 months is just baseline correction?
Yeah, it's just baseline. Yeah, because span calibration, so as I showed you before, it usually decreases between 10 and 20% in a year. So after 3 months, the decrease is minimal. So you don't need to do anything. Then it will depend on the level of accuracy that you will require for your application. If you need very accurate measurements, maybe you can calibrate the span once a year, and that will be fine. But in 3 months, yeah, there is no span decrease.
So is it recommended to do a span calibration every 12 months or?
It depends on your application. What level of accuracy you want to achieve. Because, yeah, as I mentioned before, we have some clients that the main application are industrial emissions, and they are worried about knowing if something is released or not, but they don't care about if it's 50 ppb or 55. So for that level of accuracy, maybe they don't need to calibrate the span. But if you want to measure, because your application requires very accurate measurements, maybe once a year can be fine. I don't know what are your main applications.
And just about using gas cylinders, is it something that, you know, we can introduce gas at, for example, this morning and then do the adjustment a few days later while we've got the data?
Yeah, there is no problem for that. That is very handful for the tool. So you can introduce, for example, the gas this morning, and you don't have time to go to the tool and do the procedure until next week, and it's fine. You can the next week start using the tool, select the time period in which you introduce the gas, and also you can rebuild the data of all that week that pass between the time you introduce the gas and you perform the calibration. In that case, rebuild the data will be quite useful as well.
Okay, thanks.
Any other questions? Okay, in that case, I think we can wrap up the training. I will send you the recording.
Yeah, on chat. Más antes.
So I will send you the recording of the meeting. I will send you also the slides. And please, if you try to calibrate, let me know. We can we can have a chat if you have questions, or just if you want me to check the first calibrations if they are going well. Please feel free to email me. Okay, no problem. It's a matter of practice and it takes a little bit of time.
Thank you. Just a question. Do you normally expect the customer to do calibrations themselves, or is it something that the reseller does?
It depends on the client. There are some clients that are interested in doing the calibration themselves for any particular reasons, but there are most of them, I would say, that they purchase as a calibration service. So we perform the calibration for them.
Oh, okay.
Yeah, I mean, we have different options for this case. Now we have done the training for you, okay? So you are able to perform this calibration for the final customer, okay? But in case the final customer tells you, okay, I want to do the calibration on my own, okay? We can include a training, okay, in the quotation for them. So the same training Irene has just done, we will do it for the final customer. Or other option is that include a calibration service done by Kunak. Okay, so our technical team will oversee this device, and we will be the ones in charge of doing this calibration service for the customer. Okay, so we have several options for this.
Is there actually a product code for that? Have we got that as part of?
Yeah, I mean, you said in the quotation if there is like this line, this service.
Right. I have not noticed that before, but I'll
Yeah, it exists. I can share with you guys just this service and the cost of it. Okay, this way you can just check if it's better do it yourself or you want us to do it or the final customer. This way you have all the view of it.
Thank you. I don't have any more questions. I don't know if anybody else does.
Thank you very much, Irene and Javier. Much appreciated.
Yeah, thank you.
I think you've done an excellent job, especially when you think that you've done that in another language. That's very impressive.
Thank you.
Yes.
Thank you very much.
Try to do my best.
You asked
Next one in
us.
Spanish. If
Yeah.
you want, we can do it in Spanish if you want.
Or Spanglish. Spanglish.
Don't think we'd have coped. But yeah, no, it's an excellent job. Thank you very much.
Okay.
Thank you.
Thank you.
Have a
All
good
right.
day.
Thank you.
Thank you.
Night.
Take care. Be in touch.
Yeah.
Bye.
Bye.
Okay. Take care.